as Dr. Syed Zahrul Islam. Thank you, Doctor, for this opportunity. We are from Group 3. We will present for subject Power System Operation and Control, MEK 10603. Next. My name Muhammad Shafiq bin Sahar from Group 3. Next. Okay, now we will present the title of Distribution Renewable Energy in Malaysia, which is we choose a solar lah for our group. Okay, next. Okay, at the screen we can see this is our team name and logo. Okay, from top left, we can see the logo shows renewable energy, designed to communicate a sense of sustainability, innovation, and hope. Then below, show progress. An arrow pointing up can symbolize progress, growth, and advancement. This is a common meaning in logos for companies that are focused on innovation or new product. At the right side, top one, we can see nature. Water is a natural resource, and a water drop can be seen as a symbol of connection to the natural world. This is a common meaning in logos for companies that promote sustainability or environmental awareness. The last one is we can see our tagline. There is sustainability is the ability to meet the needs of the present without compromising the ability of future generations to meet their own needs. As we know, engineering is the application of scientific knowledge to solve practical problems. Okay, next. Okay, now we can see our team organization chart. First, we go to our project manager, Muhammad Azizul Hide, IDHE 210020, expert in delegating tasks, 12 years experience. His role as a coordinate project direction and implementation. Then we go to our project planner researcher, Muhammad Hafiz Hafifi, ID number HE 210029. He is expert in problem solving analysis. He has a 9 years working experience. His role as a technical analyzer and outcome project validator. Then the last one is me as a project coordinator. My ID is HE210033, expert in engineering multitasking, 10 years experience, and my role is arrangement on data validation. Okay, next. Okay, now we go to, this is our presentation outline. Okay, first we will present about introduction, then we go to objective. After that, we go to project selection and definition, methodology, result and finding. The last one is conclusion. Okay, now I will pass this presentation to my friend Muhammad Azizul Hide.
Thanks to my colleague, Cik Syafiq Sahar. Assalamualaikum. My name is Muhammad Azizul as a second presenter on this project. Okay, from what you can see, there is the energy supply chain, which is divided by 3 stages. Number 1 is the energy commodity. The generation of electricity at power plants such as coal, oil, gasoline, derived products. Number 2 is network services. which includes transmission or moving the energy in high volumes from their source towards end user, and distribution or supplying and metering energy to end user premises. Number three is retail service, which is provide billing and managing price risk service to end user. Uh, from slide, you can see at Peninsula Malaysia, the generation capacity as of 2022, Peninsula Malaysia, total electricity generation capacity is 33,000 megawatts. The largest source of generation capacity is natural gas, which accounts for 56% of the total. Other sources of generation capacity include coal, hydro, and renewable energy, which contribute by 6%. On the demand, Peninsula Malaysia electricity demand is expected to grow at average annual rate of 18% from 2022 to 2033. By 2030, demand is expected to reach 27,000 megawatt. By the reserve margin is the amount of generation capacity that is available above and beyond demand. The reserve margin of 22% is considered to be adequate, as the 2032 Peninsula Malaysia reserve margin is 28%. At Sabah, generation capacity as 2022, Sabah total electricity generation capacity is 1,800 megawatt. The largest sources of generation capacity is hydro, which account for 25% of total. Other sources of generating capacity include natural gas 20% and renewable energy by 5%. By demand, Sabah electricity demand is expected to grow an average annual rate by 2.5% from 2022 to 2030. By 2030, the demand is expected to reach 2,200 megawatt. For the reserve margin, the amount of generation capacity that is available above and beyond demand. The reserve margin of 20% is considered to be adequate. As 2032, Sabah reserve margin is about 21%. At Sarawak, generation capacity, electricity generation capacity is 2,500 megawatt. The largest sources of generation capacity is hydro, which account for 70% of the total. Other source of generation capacity include natural gas by 25% and renewable energy by 5%. Sarawak electricity demand is expected to grow an average annual rate of 2% from 2022 to 2030. By 2030, the demand is expected to reach by 3,000 megawatt. The reserve margin is the amount generation capacity that is available above and beyond demand. The reserve margin is 20% is considered to be adequate. As 2032, Sarawak reserve margin is 20%. Renewable energy in Malaysia is a growing industry which the government committed to increase the use of renewable energy source to reduce the country reliance on fossil fuels. Malaysia has a number of resource including solar, wind, biomass and hydropower. The government has set the target of generating 20% of its electricity from renewable source by 2035. To achieve this target, the government has implemented a number of policy and initiatives, including which number one is the Renewable Energy Act 2011, which provides a legal framework for the government development of renewable energy project. Number two, the feed-in tariff scheme, which provide financial incentive for renewable energy project. Number three, the Green Investment Tax Incentive, GT, which provides tax break for companies that invest in renewable energy project. The next is objective. The objective of this study is number one is to identify distributed renewable energy DRE in Malaysia. Number two, to conduct performance comparison of the models and then select the optimized model based on performance review. Finally, provide justification on the selection. Number three, to consider case in the power system and identify variable renewable energy penetration effect. The review on the voltage and frequency level stability for the penetration of the selected renewable generation. Next, methodology. From the slide, you can see the main renewable energy source in Malaysia. Number one is solar energy is the second largest sources of RE in Malaysia, accounting about 10% of the country electricity generation. The total installed capacity of solar in Malaysia is about 1,000 megawatt. Number two is wind. Wind energy is a growing source of renewable energy in Malaysia, accounting for about 2% of the country's electricity generation. The total installed capacity of wind in Malaysia is about 100 megawatt. Number three is biomass. Biomass is a small but growing source of renewable energy in Malaysia, accounting about 1% of the country's electricity generation. The total installed capacity of biomass is about 50 megawatt. Number four is hydropower. Hydropower is the largest source of RE in Malaysia, accounting about 18% of the country's electricity generation. The total installed capacity of hydropower in Malaysia is about 4,000 megawatt. And the last one is geothermal. Geothermal energy is a very small source of renewable energy in Malaysia, accounting for less than 1% of the country electricity generation. The total installed capacity of geothermal in Malaysia is about 10 megawatt. At this slide, it's about advantage and disadvantage of renewable energy in Malaysia. Number one is solar. What the advantage of solar is solar energy is free. Number two, in sunny country, solar power can be used where there is no easy way to get electricity to remote place. Number three, handy for low power, use such as solar powers, garden lights, and battery chargers. The disadvantage of the solar is the upfront cost of installing the solar system can be high, but the long-term saving can be significant. Number two, solar energy is not available at all times, so it's often fair which the form of energy, such as battery storage or the electrical grid. Number three, solar panel need to be installed in a location that receive direct sunlight for most of the day. Number two, the advantage of the wind is free, wind farm and needs no fuel. Number two, produce no waste or greenhouse gases. Number three, the land beneath can usually still be used for farming. The disadvantage of the wind is the upfront cost of installing the one turbine can be high, but the long-term saving can be significant. Wind energy is not always available, so it's frequently combined with other forms of energy, such as battery storage or the electrical grid. Number three, for hydro. For advantage for hydro power, number one is no waste or pollution produced. Number two, much more reliable than wind, solar, and wave power. Electricity can be generated constantly by hydropower. The disadvantage of the hydropower is the dam can be negative impact on the environment by flooding and displacing people. Number two, hydro energy is not available at all time, as it depends on the availability of the water. Number three, hydro energy is only available in certain locations with sufficient water resources. Number four is biomass. The fuel tends to be cheap as an advantage. Number two, less demand on the earth resource. Number three, it makes sense to use waste material where we can. The advantage of biomass is biomass production can require land then could be used for other purpose such as agriculture or conservation. Number two, burning biomass can be produce air pollution such as particulate matter and nitrogen oxide. Biomass production many necessary the use of water, which may be an issue area which limited water resources. For project selection and evaluation, uh, I is of my colleague Encik Hafiz Hafifi. Encik Hafiz Hafifi.
Dah start ke? No?
Yeah, yes, proceed Encik Hafiz Hafifi.
Sini lah. Mana kamera aku? Boleh mula?
Proceed Encik Hafiz Hafifi.
Masih? Okay. Okay, thank you to my peer Encik Azizul Hidir. My name is Muhammad Hafiz Hafifi. I am the last presenter. So for the slide 14 is about project selection and definition. Okay, slide 15 shows some several type solar at the Peninsula Malaysia. Number one is Bukit Selambau Solar Farm, as you can see at the picture one. Number two is LSS3 Solar Project Krian, as you can see at the picture four. Number three is Jentayu Solar Park at the Terengganu. Number four is a floating solar project. Okay, now we go to Sabah, which is have at number one is Papa Solar Farm. The second one is at Tawau Solar Farm. Next we go to the at Sarawak. Number one is Bakun Floating Solar Project at the Bakun. Number two is Batang AI Floating Solar Project at Batang AI. Okay, next we go to slide 16. Next. Okay, slide 16 is about result and finding. In Malaysia, solar tariff is differ for residential, commercial, and industrial installation, as we can see at the table below. Okay, there is a type of installation for domestic is the tariff 20 cent per kilowatt hour. Next, commercial is 25 cent per kilowatt hour, and the lastly is industrial is about 30 cent per kilowatt hour. Okay, we go to for residential. Assume your home has a 3 kilowatt solar system installed. In Malaysia, the feed is feed in tariff rate for residential solar project is about 20 cent per kilowatt hour. So the feed rate is valid for 21 years. So to determine the feed for your salary system, use following the formula. If your solar system generate about 10,000 kilowatt hour of electricity per year, for example, you will receive a feed payment of 21 cent kilowatt hour multiplied by 3,000 kilowatt hour is about RM 630 ringgit per year. So that's for residential. Now we go to for commercial. Let's say you have a 10 kilowatts solar system installed in your business. The feed rate for commercial solar project in Malaysia is about 25 cent kilowatt hour. So the duration of the feed rate is about 121 years. For I give you for example, if your solar system generate about 10,000 kilowatt hour of electricity per year, you would receive a feed payment of 25 cent kilowatt hour multiplied by 10,000 kilowatt hour is about 2,500 ringgit Malaysia per year. That's for commercial. Now we go to the for industrial. Let's say you have 20 kilowatt in the solar system installed in your factory. So the feed rate for industrial solar project in Malaysia is 30 cent kilowatt hour. So the duration of the feed rate is about 21 years. For example, if your solar system generate 20,000 kilowatt hour of electricity per year, you would receive a feed payment of 30 cent kilowatt hour multiplied by 20 kilowatt hour, so it will become 6,000 per year. So next slide 18. Next. Okay. This slide is shows based on the picture there are six RE scheme being registered at the TMB. First is feed in tariff feed. Second one is large scale solar, that is called LSS. Third one is a new enhanced dispatch arrangement, it's called NEDA. The fifth one is net energy metering, NEM. Then net energy metering, NEM. And lastly is called self consumption, that is called CELCO. So next. Next. Okay, slide 19 is for conclusion. Okay, we go to slide 20. The conclusion that we can conclude is first is for residential. As of at 2022, Malaysia had over 1 million solar photovoltaic system installed, with the majority of this system being residential. In Malaysia, the feed rate for residential solar project is about 21 cent per kilowatt hour. So within every residential solar system costing around 10,000. The second one is for commercial. Uh, in Malaysia, is a significant numbers of commercial solar PV system have been installed. So in Malaysia, the feed rate for commercial solar project is about 25 cent kilowatt hour, with a commercial solar system costing around 50,000 on average. So the lastly is about for industrial. Malaysia has a small numbers of industrial solar PV system, but is growing quickly. So the feed rate for the industrial solar project in Malaysia is about 30 cent kilowatt hour, within industrial solar system costing around the 10,000 ringgit per year. So the total installed capacity solar PV system in Malaysia reached about 2.1 gigawatt by 2022. So according to the Malaysian Green Technology Corporation, Green Tech Malaysia, residential solar PV system account for 52% of this commercial solar PV system. For commercial is 38%. Industrial solar system is about 10%. So the increasing cost of the electricity, it support government for renewable energy, and growing awareness of the environmental benefit of solar energies are all driving the growth of the solar PV in Malaysia. So that's all about my presentation. So thank you enjoy for our presentation. Thank you. Okay, antap tak?
Okay, thank you.
Antap tak antap?